Good morning. Welcome to this lecture on tokenization in natural language processing. So, tokenization is one of the fundamental steps in natural language processing. It is mainly used to break the text into smaller chunks so that the natural language processing system, can recognize the text data for further processing. So we'll discuss in detail about what is tokenization, why it is required, and what are the types of tokenization. We'll also discuss some use cases in this lecture. So now we'll discuss the definition and importance of tokenization. So tokenization is a process of breaking down the text into smaller units called tokens. These tokens can be words, subwords, or characters, or sentences, which can be further processed by the model that you build. For example, when you are creating a RNN model, or a bird, or any other transformer model, robot, something, then those models can understand the data if you do this tokenization in the pre-processing stage. So pre-processing enhances the accuracy of the model and improves the efficiency as well. So it enables the model to recognize patterns, analyze structure and meaning, understand meaning of the language, uh, sentences or words or characters. So it improves the performance of NLP tasks, for example, in text classification, machine translation, sentiment analysis, or information extraction. So this will improve the performance. We will discuss with some use cases at the end of this lecture. Now we will discuss types of tokenization. There are four types of tokenization: word tokenization, sentence tokenization, uh, character tokenization, and subword tokenization. So first let's start with this word tokenization. So in this process, the given text data is split into individual words. These are called tokens. So if this process helps the system to understand each word's meaning and structure as well in text classification tasks or sentiment analysis or in other topic modeling tasks. So word tokenization helps the NLP system to extract insights from data. So in order to implement this, first you have to import this NLTK package. This is a simpler package which supports word tokenization and character tokenization. Some built-in functions are available to implement this. So first you have to download this punctuating model. So this is a tokenizer model which supports this operation. So from this NLTK module, we have the tokenize submodule. So we can import word tokenizer from this module. And initially we set the text that can be used for splitting it into words. Then we call this function word tokenize, passing this text as an argument. So it generates tokens. The tokens are in the form of words, which are split from the given text. Now we will discuss sentence tokenization. So this will split the given paragraph or large text into individual sentences. So from this NLTK tokenizer model, we are importing sentence tokenizer, and the given text is passed in this send tokenize function, which splits the given text into sentences. So it generates two sentences. Natural language processing is fascinating. This is the first sentence, and second sentence, it has many applications. These two sentences will be generated as output. Now we'll discuss subword tokenization. So in some cases we have complex sentences with special characters or combined words, so which makes the natural language processing difficult. So now to handle that challenge, we have to generate tokens called subwords, which divides the complex words, combined words into separate words. For example, unhappiness can be split into unhappiness. So if we split like this, then the model can understand the smaller words and meaning of the words. Even it can handle out of vocabulary words. So for example, when we have mail IDs or some special characters in the sentence like this, so data science engineering is the best lecture for students and teaching community. So if we divide this into smaller chunks, then even the combined words which include some special characters will be splitted into separate tokens, so the model can easily understand. So in this example, we have used a regular expression package to split the given text into subwords. So all subwords of the given sentence will be generated, including the special characters. Everything will be splitted into separate unit. So in the next example, we have a character tokenization technique. So this splits the given sentence or the word into individual characters. So this will improve the performance in handwritten character recognition or in language modeling. Now let's compare these approaches. Word tokenization breaks a given sentence into words. It is more suitable for languages containing word boundaries. For example, English language. And then character recognition splits given text into individual characters. It is useful for languages which is not having word boundaries or which requires more detailed analysis, granular analysis. Then the subword tokenization generates subwords from the larger text and generates smaller words, special characters, and other units of the given text. And it is useful for languages having complex morphology. For example, Chinese, Japanese languages will not be having the white space between words, or handling out of vocabulary words can be done using this approach. Now let's discuss challenges in tokenization. So when we have punctuation symbols, special characters, it will complicate the tokenization process. For example, the email ID will be having dot symbol and at symbol, some special characters and all, and addition to the words. So we have to take care of these things while handling the tokenization. And the tokenization model should incorporate rules to split the given input into learnable pattern, and it should ensure consistency. And also there may be ambiguity in the process due to proper word boundary, or for example, in the sentence, flying planes can be dangerous is a given sentence. So if you split this into tokens in different ways, so it generates uh, smaller individual units. So depending upon the tokenization, the meaning of the words or phrase will change. For example, it may convey the meaning piloting planes is risky, or planes in flight poses a danger. So this causes ambiguity and interpreting the meaning of the words or phrases in the sentence. So the next challenge is when we have um, complex language, for example Chinese, which do not use space between words. So we have to give more importance in handling different structures present in the language. So it should determine the one word boundary and the beginning of another word boundary carefully. So now to address challenge, there are advanced models. For example, XLM or cross-language model robot uses subword tokenization. It is quite useful for large-scale pre-training. It can handle 100 more than 100 languages effectively, including the languages which are not having clear word boundaries can be handled. And MBOT, which is a multilingual board, it employs word-speech tokenization. It has shown good performance in various languages. It can use multiple languages as well. Understanding syntactic, semantic structures, it can generate the target language. So these models are quite useful, not only in tokenization but also effectively handle the language structure and understanding the meaning, contextual information to generate the target information. So we have now use cases. We'll discuss some use cases. For example, Google uses speech recognition. For example, the given speech can be converted into text, and the text is divided into tokens, which can be recognized by the search engine to extract, retrieve information from documents. So it can generate more relevant results to our query. And in machine translation, the given source sentence can be divided into smaller units, which can help the language model, NLP model, to translate and generate the target language, ensuring the accuracy and the contextual awareness. And speech recognition, voice virtual assistant, for example Siri or Alexa, uses tokenization process. It divides a given query or commands into manageable units. So this text is tokenized. It allows the system to process and provide the necessary response. In sentence and sentiment analysis also, to understand the meaning, emotions, or the contextual uh, meaning of the word. So this tokenization is widely used to extract insights from generated content. So the given customer reviews or social media posts can be divided into smaller units called tokens, which can help the sentiment analysis system to generate uh, target output, which can have mixed labels to provide necessary insights to the businesses. And in chatbot and virtual assistant also, it is used to understand the text and respond to the user query. For example, the given sentence, I need to reset my password, can be tokenized as I need to reset my password. These are all the words generated from this given sentence. We have applied word tokenization, and this process helps the chatbot to understand and identify what the user want. So understanding that the user request for resetting the password, it can generate necessary links and instructions to the user. And then the next process, text classification, also it plays a very important role. Understanding the text meaning of the words, you can classify the text into news text, business text, or entertainment text, sports related, or other text related to politics, something like that. So it can play a very important role in news analysis as well. And in named entity recognition, tokenization is used to identify named entities like disease names, symptoms name, people name, organization names, other names, to understand and predict the relevant class of the labels, relevant class of the named entities. And it helps the information extraction system to extract necessary information around entities, and it allows models to recognize and classify entities more accurately. We have several tools, libraries for tokenization. For example, a bird tokenizer is one of the popular tokenizer. It uses a pre-trained model to implement a context-aware tokenization. It can handle nuances and ambiguities of a language. It makes it a top choice for advanced NLP projects. And NLTK is one of the popular library that provides simple functions for word and sentence tokenization. And another package is a spacey library. A spacey library is most powerful for improving the efficiency in large scale text processing. It is used to deal with complex linguistic structures. And we have another library, Hugging Face Transformers. It provides a seamless integration with PyTorch. It is a good choice for research and production related projects. We can use this library for generating tokens to work with advanced models like bird, generative AI model, robot, and other models. So there are three key features. It supports fast organizations. It supports for support organization. It has a feature for pre-trained tokenizers. So it uses built-in Rust concept, which is used in building this fast tokenizer. So this tokenizer generates tokens, improving the speed and in the pre-processing stage for large data set. It supports byte pair encoding, word keys, and unigram tokenization. It improves the efficiency of handling out of word, out of vocabulary words and complex language structures, and understanding the meaning of complex words. It has built-in pre-trained tokenizer. So the model that is trained using this Hugging Face transformers comes up with a pre-trained tokenizer. It ensures compatibility and the ease of use. So it splits the given text into subwords. It makes it suitable for language understanding. So thank you all. In the next lecture, we'll discuss about morphological analysis, and also we'll discuss TF IDF factories. Thank you all.